Hi everyone, welcome back to Information Economics. Today we're going to introduce again a screening model, but now we're going to change the technical assumption. We're going to introduce the continuous type screening model. So in this video, I'm going to give you an introduction and overview of our plan. And then we're going to first introduce some mathematical preliminaries that you need to have for you to characterize the optimal contract. We then use those tools to really derive the optimal contracts to you, and finally gives you some implications of that. Okay, so recall that we introduced the monopoly pricing screening problem to you with two kinds of consumers. Okay, we assumed that consumers have a private type theta, which may be theta low or theta high, and the theta low means the consumer is not so willing to pay for this product. The seller believes that there is a distribution for theta. From the seller's perspective, theta is random, which may be theta L with some probability and theta H with some other probabilities. Once obtaining Q units by paying T, a type theta consumer's utility is denoted in this way. Okay, theta times V of Q minus T, where V of Q is a strictly increasing and strictly concave function. And if the consumer does not eat anything, the consumer gets nothing. Okay, so that's the standard setting we introduced with our two-type model. There are some other things. The unit production cost is C, which is less than theta L. By selling Q units and receiving T, the seller would earn T minus CQ. So this is the seller's profit function or utility function. The question is how to price the products so that we may maximize the expected profit. Okay, so that's the seller's contract design problem about choosing the prices for the products with different quantities. Because we assume that there are two kinds of consumers, so we say this is a two-type screening model. Okay, so very quickly let's review what's that. The two-type screening model can be formulated in this way. We're going to have two contracts, a menu of two contracts to be designed because there are two types. Okay, two types, so we design two contracts, one for the high type, one for the low type. We know this is optimal. This can be optimal because we have a revelation principle. Okay, given that the high type and the low type will choose the contract THQH and TLQL, we know that this is our expected profit. The first two constraints are incentive compatible or truth-telling constraints. That means if you are a high type consumer, you prefer the high contract than the low contract. Or if you are a low type consumer, you prefer the low contract. The last two constraints are the individual rationality or participation constraints. Okay, by choosing the high contract or the low contract, the high type consumer and the low type consumer, they can earn a positive utility, non-negative utility. We can use some ways to solve this problem. Okay, under a certain condition, the optimal menu, this should be small t. Okay, small t. Your optimal menu would be satisfying this and that. Okay, and we mentioned to you that this tells you that we have efficiency at top. Okay, for the high type, the quantity is efficient. Here we have downward distortion. For the low type, the quantity is distorted downwards. Okay, we also have monotonicity. We also have no rand at bottom. If you have forgotten what are them, you probably need to do some brief reviews. Now we ask one question. May we generalize this problem to n types? Okay, because no one says consumers would only be of two kinds. There may be more than two kinds. So let's see whether we can do it or not. Okay, so in a general setting, theta may be of types theta 1, theta 2, up to theta n, and theta 1 is the smallest, theta n is the largest. Now we say, okay, for probability of theta to be theta I, let's say it is beta I. Okay, so beta I is the probability. And then the n-type screening problem is formulated in this way. Again, this is the expected profit, given that all types of consumers will choose the contract intended for them. And then this is IC, this is IR. For a type I, for a consumer whose true type is type I, okay, he would prefer choosing contract I to choosing some other contract J. So we need that to have for all I, for all J, that's IC constraint. Also, we have IR constraint to make sure that all types of consumers are willing to participate. Okay, so we can formulate this. May we find the optimal menu? The answer is yes. We can do some derivations and show that the problem can be reduced to this. The objective function is the same, but for the constraints, first, only those local downward IC constraints are necessary. Okay, so it's here. We only need to make sure that type 2 does not want to pretend to be type 1. Type 3 does not want to pretend to be type 2, and so on and so on. So you don't need to worry about whether type 1 wants to pretend to be type 5, whether type 7 wants to pretend to be type 2. Well, you don't need to worry about that because they are all redundant. You have the intuition for that, you have the derivation for that. There's no problem for that. Also, only one IR constraint would be necessary, which is the lowest one. Okay, which is the lowest one. The one for the type theta 1. So here we actually have some intuition about that. If you like the product, you're going to pretend that you don't like the product. That's why you only need downward IC to prevent that to happen. You also only need local IC because if you can prevent 3 from pretending to be 2, prevent 2 from pretending to be 1, then with some very naive derivations, you can show that 3 would also have no incentive to pretend to be 1. For IR, it's the same thing. If you have a chance to lie, you have the threat to lie, then you receive some information rent. That happens as long as you are not of the lowest type. Okay? So only the lowest type would be bounded below by an IR constraint, and eventually he is going to receive no rent. So we still have no rent at bottom, we still have efficiency at top that can be shown, and we also have monotonicity. Eventually Q1 would be less than Q2, less than Q3, and so on and so on. So this is fine. We can still proceed to solve all this problem and find the optimal contracts to you. But let's do one more step. May we generalize this problem again to infinitely many types on a continuum within an interval. So what does that mean? Let's see the formulation. Suppose theta now may be anything, any value within an interval theta 0 and theta 1. Okay? Theta 0 is a value that is less than theta 1, and now we have an interval. Theta may be anything on it. So now, from the seller's perspective, theta is random, and now you cannot assign probabilities to possible values of theta, because now you have infinitely many possible values of theta. So you're going to have a continuous random variable. That's why you need F and capital F to be the PDF and CDF for your random variable theta. Okay, I don't know what's theta because theta is random, but I know it's PDF and CDF. And that's my belief on the random type or the private type. Then our continuous type screening problem can be formulated in this way. First is the objective function. Well, even though now you are looking at an integral with some PDF here, you know this is trying to calculate the expected profit of the seller. Okay, because you have so many different types of consumers. Each type is going to be induced to select the contract that is intended for him. Okay, so he is going to pay T of theta amount of money and obtain Q of theta units of products. So for type theta, you're going to earn this, and you have all these types. So you find the weighted average of the earning in that case with that likelihood. So this is your expected profit for the continuous type model. And then for all the types of consumers, they have the choice to misreport their type, to lie about their type. So here, they should choose Q theta, T theta, but they have the chance to choose Q theta hat, T theta hat. We need to make sure that choosing the right contract is the best for them. And finally, we need to make sure that choosing the right contract can earn a non-negative utility. Okay, so this is exactly a generalization from the two-type or the N-type model. Then now, let me remind you one thing. You have so many variables, right? Or you have infinitely many Q, infinitely many T. For each type, you are going to assign two values, Q and T, to him, and he is going to select that contract. So you are going to offer really an infinitely many contracts in your menu. So you are going to optimize this problem where your decision variables are actually functions. Okay, functions. You want to find two functions to maximize your expected profit. That's the problem. Okay, today we're going to tell you how to solve this problem and find the optimal menu, and show you that all the original implications you had will still be true, and we can extend them to some other things that you cannot do without a continuous type model. Okay, so that's the plan for today. Thank you.